resulting discussion of salivary amylase as a stress marker and the kinetics of an industrial amylase. Amylase is the primary enzyme in saliva that acts on starch in food and breaking it down into maltose, a smaller form of carbohydrate. In order to understand the reaction of amylase upon starch, we would have to prepare the standard reference, a standard curve of different starch concentration versus absorbance. We didn't get the actual result because of the improper technique in handling the spectrophotometry. But, for the sake of learning purpose, we had changed the absorbance values of all samples. So, we assume this is our data of standard reference. From the data, we plot a curve of standard reference. For salivary amylase activity prior to stress marker in humans, one of our group members decided to watch a video that could trigger her anxiety disorder, specifically known as obsessive-compulsive disorder. The process that actually happened in our body when the stress level gets high is the immoderate production of salivary amylase takes place. Data of substrate concentration effect using industrial amylase. Michaelis-Menten graph of substrate concentration effect using industrial amylase. Graph of 1 per starch concentration versus 1 per rate of digestion. Value of maximum velocity and Michaelis constant obtained from the graph. The enzyme concentration stays the same throughout the experiment, whereas the concentrations of the substrate, which is the starch, are in increasing order. The actual reason of how the iodine turns the color of the starch into blue is because of the long polymer chains of glucose called amylose contained in the starch. Data of temperature effect using industrial amylase for 4 degrees Celsius. Data of temperature effect using industrial amylase for 35 degrees Celsius. Data of temperature effect using industrial amylase for 40 degrees Celsius. Lineweaver-Burke line of the result of 4 degrees Celsius, 35 degrees Celsius and 40 degrees Celsius. Value of maximum velocity and Michaelis constant obtained from the graph. Amylase has a temperature that works optimally around our body temperature, but in this case, 35 degrees Celsius would consider as optimum compared to the remaining temperature, since the reaction rate at 35 degrees Celsius is high, but when it comes to 4 degrees Celsius and 40 degrees Celsius, both of reaction rates are really low and the plotted values located near to each other. This is because when the temperature is too low, the enzyme reaction becomes deactivated, whereas high temperature led to enzyme denaturing and it becomes completely destroyed. In short, we could say that the enzyme activity is strongly affected by substrate concentration and also temperature.